Let's take a look at the S block elements, and let's try to understand why they're called the S block elements. If you look at hydrogen, electron configuration is 1s1. Lithium, okay, comes after helium. So after helium, the next orbital would be 2s, so 2s1. So you can see the valence shell is the second shell. Sodium comes after neon. So after neon core, you fill in your 3s orbital. So this is the third row. The outermost shell has a 3s orbital with 1 electron. So what do you think potassium is going to be? Potassium comes after argon. So it's going to have an argon core, okay? And then potassium is in the fourth row. After the argon core, the next subshell to be filled is the 4s, so argon core 4s1. Okay. Rubidium comes after krypton, so one more electron than compared to krypton, so it's going to have a krypton core, and then the next orbital to be filled would be the 5s orbital, so 5s1. So this is row number 5. And then cesium comes after xenon, so it's going to have a xenon core, and then after that, one more electron. That extra electron is going to be in the 6s orbital. So what do you notice? What do all of these have in common? Their valence configuration, we say, is ns1. Okay? Let me write that. ns1. So the valence configuration for these elements is ns1. What do you think the valence configuration for these elements are going to be? Group 2a. One more electron, so the valence s electron can accommodate one more electron. It can accommodate up to 2 electrons, so you would expect all of these to have a valence configuration of ns2. Okay? So beryllium comes after lithium. So if lithium is helium core 2s1, beryllium is helium core 2s2. Magnesium, okay, let's see. Magnesium comes after sodium, so if sodium is neon core 3s1, then magnesium is neon core 3s2. Calcium comes after potassium, so it's going to be neon core, and then it's in the fourth row, so 4s2. Okay, strontium comes after rubidium, so strontium would have argon core. Instead of 4s, I'm sorry. Oops, I got it wrong. Calcium would have an argon core 4s2, and then rubidium is going to have, strontium is going to have a krypton core, and instead of 5s1, you get one more electron, that's 5s2. And then barium, okay, instead of 6s1, it's going to have 6s2 as the valence configuration. So that's what they all have in common. And that's why these elements right here are known as the S block elements.